Hi, I'm Femi. Welcome back to our series in solving key trigonometry and calculus examination questions. In today's video, we are going to solve three important problems that involve trigonometric function making use of quotient rule, product rule, and chain rule. But before we dive into the video, I'm going to need to share with you some very important trigonometric identities that is going to be very useful to you, whether you are working on differentiating trigonometric functions or you are working on other concepts under trigonometry. I will be back shortly. I decided to treat these three questions in a single video. The purpose is to clarify when to use quotient rule, when to use product, and when to use chain rule. Now let's start with question 2a. So here we are required to prove that if y is tan x, then dy dx is sec square x. Now we can easily recall that tan x is the quotient of sine x and cos x. So we can easily rewrite that expression, that equation, we can rewrite it as y is equal to sine x over cos x. So for the fact that we are now having one expression being used to divide another expression, that simply means that we are going to use quotient rule to determine our dy dx. Now, if you can remember in our last video, to apply quotient rule, what we have is v du dx minus u dv dx, everything divided by v squared. So our numerator here stands for u, our denominator stands for v. So we can have u to be sine x, and we have v to be cos x. So we have an expression for u now, we have an expression for v. So we need to determine du dx and dv dx. So we get our du dx from here. So du dx becomes the differential of sine x, and that becomes cos x. And our dv dx, when you differentiate cos x, we have minus sine x. So let's split the board here so that we can have the remaining part of the solution on the other side. Now we just need to substitute all these expressions for our variables in the formula here. So we can eventually have the y dx. Our v takes the place of cos x. Then du dx cos x minus our u is sine x. We have sine x. Then dv dx is minus sine x. So let's manage that space on the board. Minus sine x. So we now use this to divide our v here is cos x. So that becomes cos x all squared. Now from what we have here, Cos x multiplied by cos x will give us cos square x. Don't forget that cos x all squared is exactly the same thing as cos square x. Our negative here, we multiply the negative here, and that becomes positive. So we have plus here, and sine x will give us sine square x. We use that to divide cos x squared, and that can also be written as cos square x. Then from our trigonometric identities, and that is why we always need to have that handy. Now, cos square x plus sine square x will give us 1. So therefore, dy dx will now become 1 divided by cos square x. So 1 divided by cos square x will always come back to be sec square x, and that is what we are required to prove. So our final answer here is sec square x. Now let's proceed to question 3b. Here we are asked to derive dy dx if y is equal to 3x cos x. So this is a product of two functions. We are using 3x to multiply the trig function cos x. So therefore, we are going to apply the product rule. And here is what the product rule looks like. We have dy dx to be v du dx plus u dv dx. Please take note that either of these can come first as long as we are making use of addition. So this can come first and this can come second. Either of the two can always be replaced into their position. So if this is how to apply our product rule, then we can easily take our variables from the question. So here we can have u to be 3x and can have v to be cos x. So we have an expression for u and v. So we now need to derive the expression for du dx and dv dx. So for du dx, we can have our du dx from this equation. So du dx simply means we are differentiating u with respect to x, and here we have 3, and when we take dv dx, so that is differentiating cos x, and whenever we differentiate cos x, we always have negative sine x. So now we can put all this back into our equation here. So eventually we now have dy dx. So our v is cos x, du dx is 3 plus u is 3x, and dv dx is minus sine x. So when we simplify further, cos x multiplied by 3, the number will come before the trig function. So we have 3 cos x, then plus and negative will multiply to give us negative. So 3x multiplied by sine x will give us 3x sine x. So this is what our answer looks like. It's as simple as that. Now let's take a look at question 4b. This is a function raised to a power, so therefore we have to apply chain rule. Now, the principle behind chain rule is that we use a different variable for the inner function. So we take the derivative of the outer function, we now use it to multiply the derivative of the inner function. That is how chain rule works. Let's put that into practice. So we use a different variable. Let t be equal to sine x. So you can use any letter of your choice as long as it is not y and x. So if t is equal to sine x, that simply means that we can rewrite this equation as y is equal to t raised to the power of 3. So this is now replacing, t is now replacing our sine x. So we can have this as y is equal to 3 raised to the power of 3. So eventually, our chain rule says that dy dx is equal to, we differentiate the outer function, then we now differentiate the inner function. So for the outer function, we have it as dy dt, and for the inner function, we have it as dt dx. We'll multiply this by dt dx. So our dt dx here, our dt dx can easily give us dt dx, that will give us cos x, and dy dt will give us 3t raised to power 2. So let's substitute all these expressions into our equation here. So what we have is for dy dt, we have 3t squared multiplied by dt dx is cos x. So what we now do is that we have to replace the expression that we use for t, because t was never part of our question. We inserted t to make it easier for us to apply the chain rule. So our t here is sine x. So we now have 3 into sine x squared multiplied by cos x. So we can now finalize this by writing it as 3 sine square x, then cos x. So this is our final answer. So what I actually want you to understand here is that if you take a look at the 3 questions, you can easily see that the first one we solved has to do with division. So once you see 2 expressions being used to divide one another, then we are going to apply quotient rule. And for the second question, the 2 functions are being used to multiply each other. Then we were having 3x multiplied by cos x. So in that case, we make use of product rule. And in this case, we have a function being raised to a power. So once you see something like that, what we do is that we apply chain rule. So make sure you don't make the mistake of confusing yourself of when to use product, quotient, and chain rule. And that's it for this video. This brings us to the end of this part of the series. In the final part, we are going to shift focus to the last 2 questions involving trigonometric identities and angle formula. So make sure you subscribe and hit the bell so you don't miss out on it. See you in the next video. Thanks and God bless you.